Hi everyone, this is Lance Harmer. I'm going to be presenting what I did for assignment 3 in medical robotics. So first we take 10 plus, actually 20 images of this checkerboard pattern in various positions, 10 of which we know are known distances from one another. So this first 11 are in increments of 10 millimeters apiece. So what we do is we go into the MATLAB function and say calib underscore GUI. It'll bring up this. We'll just say standard, for example. So what we do is we read the images, and here you can see it loads all of the pictures. When you go extract grid corners, we'll just say do all of the pictures, and then the grid sizes, and like this. So then in here, we select the grid corners like this. 1, 2, I'm going to fast forward here so that we get through all of them, but for all the 21 pictures that I have, we're going to be doing this. For each one, it'll show you kind of what the output was. So at the end, I will that each picture from the our grid coordinate system was. So that's about right. There were a bunch that were across this plane here when we were trying to do our known distances. So for that particular part, we're going to go show extrinsic so we can calculate the exact coordinates. I'm sorry there. So 5, 5. Okay, so what we'll do is just pull the corners on each of these, and then once we get that going, just enter some of the parameters that it needs to be able to calculate. So once it gets that, it'll output a little matrix here giving us our translation, rotation, etc. So this is what we're kind of interested in because we know how much we incremented a certain coordinate. In this case, it was 10 millimeters or 1 centimeter. So what we did was we got each of these for the 10 different pictures of known distances, came over into this Excel sheet, and then you can see here's our first point with those 3 parameters and all the way down through. Looking at this, you can see that our x-coordinates incremented by about 10 millimeters each time. These were approximately the same, although compensating for a little bit of skewing in the picture taking. So after that, we made a couple plots, distance from previous origin. So this is from point to point. You can see how much it was supposed to have changed, exactly 10 each time, but it got a little off skew. And then here you can see over the course of the 10 pictures how far it went. So it's just trying to represent the accuracy of the camera calibration. So this is the last portion of the assignment. We have initial and final coordinate points, and then finding the transformation matrix between the two. So it's going to be calling this find transform function here, which refers to this objective function, which we have loaded in here. All this is doing is calculating the error between the 2 points systems, the 2 coordinate systems, I mean. So over here, using the fmin search, it's going to optimize to find the smallest value of error. Once that's done, it will output the result in some function, or here we go, in the command prompt. So we have this extremely small error after the optimization, and then here are the angles for phi, theta, and psi. So this is basically just trying to find the angle inputs that are going to cause this function to be minimized. I hope this all makes sense. If you have any questions, please feel free to leave them in the comments. Thanks. Bye.